Hey everyone, I'm making a short video about direction angles. So first we're going to look at 2D. So looking at my Tinker Toys here, if you can see this says X, the X-axis, and this says Y, the Y-axis. So right now I'm looking at my XY plane and I'm actually going to pull out my Z-axis. So we're only looking at 2D. So here's my positive x-axis, here's my positive y-axis. If I have my force right here, theta x is the angle between the force in question and the positive x-axis. So there's an angle here of, let's say, about 45. Let's do it less than 40. So it's about 40 degrees. And if the force is still here and it's 40, then it's theta y, the direction angle theta y is the angle between the force in question and the positive y-axis. So that angle right here would be 50 degrees. If this is 40, this is 50. Okay, now let's look at a force over here. If a force is here, and let's say this degrees right here is 30 degrees, the direction angle of theta y from the force in question to the positive y-axis is 30 degrees. This is 30 degrees. So a direction angle does not have a positive or a negative. It could never, rather, it could never be negative. It has to be positive. So we have 30 degrees. So now the question is, what is the direction angle between the force and the positive x-axis? Well, if this is 30 degrees and this is 90, the theta x would be 120 degrees. But remember on my longer video, each theta angle actually, direction angle actually has two values. So theta x could be 30 plus 90, which would be 120, or I could go in the other direction. I could say it's 60 plus 180. So 60 plus 180 is 240. Okay, so let's have a force down here now. Again, this is the x-axis and this is the y-axis. And this angle right here is my theta x, or the angle from here to here is theta x. And theta y is from here to here. And the reason that you go in both directions, remember in engineering, we always use the cosine of the theta. So whether I go cosine of this angle or cosine of this angle, I'm going to get the same value. So that's 2D. Let's add the third component now. So here's x-axis, y-axis, and now I have the z-axis pointing out at you. So if we have a force here in our first quadrant where everything is positive, the angle here, the angle here, and the angle here, these are the direction angles. It's really like the shortest distance, the shortest angle to the z, the shortest angle to the y, and the shortest or the smallest angle to the x. And because in this case, the force has a positive, it's positive in all three directions, those direction angles are going to be acute. But let's look at a situation where we have my force vector. The force vector is below. Let me move out. It's below. It still has an acute angle to z, and it has acute angle to x because they're positive. But this force has a negative y. So the direction angle from this force up to here is going to be obtuse. Okay? And now I'm going to show you a table. So I'm going to change this now to setting it up. Setting it up on my screen. I'm going to come down a little so it's closer. And I'm going to focus in. And I do have to mirror the image. Unmirror the image, rather. Okay, so now you see my my paper here. Great. And I have a table set up. So let's look at this. In this particular case, you notice that the directions of the axes I chose is different, right? And now the XY plane is the horizontal plane and the Z axis represents the elevation. So X axis is coming out at us, Y positive is to the right, and YZ is above us. So what I try to do here is draw all the different octants we possibly have. So let's say our force goes from this origin point out here. Let's say this is where our force is. Let me make it a little darker. You're going to start using 3D spatial visualization skills. And those of you who have taken Engineering 25, spend a lot of time developing them. So let's take a look. This force is going from the front. Let's make this box. Can you see this box? In essence, what's happening is here's my box. And the force is going from this point to this point. This is my force vector. And this right here is where my Y is, and this is where my X is coming out, and this is where my Z is. This may look a little clearer because there's not so many lines. But basically going from the front bottom corner, right bottom corner, to the top back left corner, this force is going in the negative X direction. Going from the front bottom right corner to the top back left corner is going in the negative Y direction. But the force is going in the positive Z direction. So if we have a situation where, I'm not sure what octant this is, 1, 2, 3, I'm not sure, let's just call this octant 3. So in this particular case of octant 3, it's going in the negative X, it's going in the negative Y, and it's going in the positive Z. So tell me what's going to be happening with our delta, our theta X rather, the direction angle in the X. If it's a negative X, the angle is going to be acute. Theta Y, oh, sorry. Because it's a negative, it's going to be obtuse. Theta Y, since it's negative, is going to be obtuse. Theta Z, since it's positive, is going to be acute. Because looking at this picture here, or even the one below, you could see that the force is going up here, and there is an acute angle between the force itself and the positive Z axis. But it's going to have an obtuse angle coming down to the X axis and an obtuse angle coming to the Y axis. Let's do another one. Let's do one where it's positive X. Let's do negative Y again. Negative Y and negative Z. So in this particular case, my force, again, let's start it at the origin. It's going in the positive X direction. It's going in the negative Y, so it's going this way. It's going up this way. And it's going in the negative Z. So that means that this force is really going down here. It's going in the positive X direction. It's going in the negative Z direction, sorry, negative Y direction, and also in the negative Z direction. So in the positive X, theta X is going to be acute because it's positive. Y is going to be obtuse. And theta Z is going to be obtuse. Okay, I'm going to stop the tape.